Appendix E. Sample Fall Protection Plan Non-Mandatory Guidelines for Complying with 1926.502 K. Employers engaged in leading-edge work, precast concrete construction work and residential construction work who can demonstrate that it is infeasible or creates a greater hazard to use conventional fall protection systems must develop and follow a fall protection plan. Below are sample fall protection plans developed for precast concrete construction and residential work that could be tailored to be site-specific for other precast concrete or residential job site. This sample plan can be modified to be used for other work involving leading-edge work. The sample plan outlines the elements that must be addressed in any fall protection plan. The reasons outlined in this sample fall protection plan are for illustrative purposes only and are not necessarily a valid, acceptable rationale, unless the conditions at the job site are the same as those covered by these sample plans, for not using conventional fall protection systems for a particular precast concrete or residential construction work site. However, the sample plans provide guidance to employers on the type of information that is required to be discussed in fall protection plans. Sample Fall Protection Plans. Fall Protection Plan for Precast/Pre-Stress Concrete Structures. This fall protection plan is specific for the following project: location of job, erecting company, date plan prepared or modified, plan prepared by, plan approved by, plan supervised by. The following fall protection plan is a sample program prepared for the prevention of injuries associated with falls. A fall protection plan must be developed and evaluated on a site-by-site basis. It is recommended that erectors discuss the written fall protection plan with their OSHA area office prior to going on a job site. Statement of company policy. Company name is dedicated to the protection of its employees from on-the-job injuries. All employees of company name have the responsibility to work safely on the job. The purpose of this plan is A. To supplement our standard safety policy by providing safety standards specifically designed to cover fall protection on this job, and B. To ensure that each employee is trained and made aware of the safety provisions which are to be implemented by this plan prior to the start of erection. This fall protection plan addresses the use of other than conventional fall protection at a number of areas on the project, as well as identifying specific activities that require non-conventional means of fall protection. These areas include: at connecting activity, point of erection. B. Leading edge work. C. Unprotected sides or edge. D. Grouting. This plan is designed to enable employers and employees to recognize the fall hazards on this job and to establish the procedures that are to be followed in order to prevent falls to lower levels or through holes and openings in walking/working surfaces. Each employee will be trained in these procedures and strictly adhere to them except when doing so would expose the employee to a greater hazard. If, in the employee's opinion, this is the case, the employee is to notify the foreman of the concern and the concern addressed before proceeding. Safety policy and procedure on any one project cannot be administered, implemented, monitored, and enforced by any one individual. The total objective of a safe, accident-free work environment can only be accomplished by a dedicated, concerted effort by every individual involved with the project from management down to the last employee. Each employee must understand their value to the company, the costs of accidents, both monetary, physical, and emotional, the objective of the safety policy and procedures, the safety rules that apply to the safety policy and procedures, and what their individual role is in administering, implementing, monitoring, and compliance of their safety policy and procedures. This allows for a more personal approach to compliance through planning, training, understanding, and cooperative effort, rather than by strict enforcement. If for any reason an unsafe act persists, strict enforcement will be implemented. It is the responsibility of name of competent person to implement this fall protection plan. Name of competent person is responsible for continual observational safety checks of their work operations and to enforce the safety policy and procedures. The foreman also is responsible to correct any unsafe acts or conditions immediately. It is the responsibility of the employee to understand and adhere to the procedures of this plan and to follow the instructions of the foreman. It is also the responsibility of the employee to bring to management's attention any unsafe or hazardous conditions or acts that may cause injury to either themselves or any other employees. Any changes to this fall protection plan must be approved by name of qualified person. 2. Fall protection systems to be used on this project. Where conventional fall protection is infeasible or creates a greater hazard at the leading edge and during initial connecting activity, we plan to do this work using a safety monitoring system and expose only a minimum number of employees for the time necessary to actually accomplish the job. The maximum number of workers to be monitored by one safety monitor is 6. We are designating the following trained employees as designated erectors, and they are permitted to enter the controlled access zones and work without the use of conventional fall protection. Safety monitor, designated erector. The safety monitor shall be identified by wearing an orange hard hat. The designated erectors will be identified by one of the following methods. 1. They will wear a blue-colored armband, or 2. They will wear a blue-colored hard hat, or 3. They will wear a blue-colored vest. Only individuals with the appropriate experience, skills, and training will be authorized as designated erectors. All employees that will be working as designated erectors under the safety monitoring system shall have been trained and instructed in the following areas. 1. Recognition of the fall hazards in the work area, at the leading edge and when making initial connections point of erection. 2. Avoidance of fall hazards using established work practices which have been made known to the employees. 3. Recognition of unsafe practices or working conditions that could lead to a fall, such as windy conditions. 4. The function, use, and operation of safety monitoring systems, guardrail systems, body belt/harness systems, control zones, and other protection to be used. 5. The correct procedure for erecting, maintaining, disassembling, and inspecting the systems to be used. 6. Knowledge of construction sequence or the erection plan. A conference will take place prior to starting work involving all members of the erection crew, crane crew, and supervisors of any other concerned contractors. This conference will be conducted by the precast concrete erection supervisor in charge of the project. During the pre-work conference, erection procedures and sequences pertinent to this job will be thoroughly discussed and safety practices to be used throughout the project will be specified. Further, all personnel will be informed that the controlled access zones are off limits to all personnel other than those designated erectors specifically trained to work in that area. Safety monitoring system. A safety monitoring system means a fall protection system in which a competent person is responsible for recognizing and warning employees of fall hazards. The duties of the safety monitor are 2. 1. Warn by voice when approaching the open edge in an unsafe manner. 2. Warn by voice if there is a dangerous situation developing which cannot be seen by another person involved with product placement, such as a member getting out of control. 3. Make the designated erectors aware they are in a dangerous area. 4. Be competent in recognizing fall hazards. 5. Warn employees when they appear to be unaware of a fall hazard or are acting in an unsafe manner. 6. Be on the same walking/working surface as the monitored employees and within visual sighting distance of the monitored employees. 7. Be close enough to communicate orally with the employees. 8. Not allow other responsibilities to encumber monitoring. If the safety monitor becomes too encumbered with other responsibilities, the monitor shall 1. Stop the erection process, and 2. Turn over other responsibilities to a designated erector, or 3. Turn over the safety monitoring function to another designated, competent person. The safety monitoring system shall not be used when the wind is strong enough to cause loads with large surface areas to swing out of radius, or result conditions cause the walking working surfaces to become icy, or conditions cause the walking working surfaces to become icy or in loss of control of the load, or when weather slippery. Control zone system. A controlled access zone means an area designated and clearly marked, in which leading edge work may take place without the use of guardrail, safety net, or personal fall arrest systems to protect the employees in the area. Control zone systems shall comply with the following provisions. 1. When used to control access to areas where leading edge and other operations are taking place, the controlled access zone shall be defined by a control line or by any other means that restricts access. When control lines are used, they shall be erected not less than 6 feet, L.8 m, nor more than 60 feet, 18 meters, or half the length of the member being erected, whichever is less, from the leading edge. 2. The control line shall extend along the entire length of the unprotected or leading edge and shall be approximately parallel to the unprotected or leading edge. 3. The control line shall be connected on each side to a guardrail system or wall. 4. Control lines shall consist of ropes, wires, tapes, or equivalent materials, and supporting stanchions as follows. 5. Each line shall be flagged or otherwise clearly marked at not more than 6 foot, 1.8 m intervals with high visibility material. 6. Each line shall be rigged and supported in such a way that its lowest point, including sag, is not less than 39 inches, 1 meter from the walking/working surface, and its highest point is not more than 45 inches, 1.3 meters from the walking/working surface. 7. Each line shall have a minimum breaking strength of 200 pounds, 0.88 kN. Holes. All openings greater than 12 inches. X 12 inches. Will have perimeter guarding or covering. All predetermined holes will have the plywood covers made in the precaster's yard and shipped with the member to the job site. Prior to cutting holes on the job, proper protection for the hole must be provided to protect the workers. Perimeter guarding or covers will not be removed without the approval of the erection foreman. Precast concrete column erection through the existing deck requires that many holes be provided through this deck. These are to be covered and protected. Except for the opening being currently used to erect a column, all opening protection is to be left undisturbed. The opening being uncovered to erect a column will become part of the point of erection and will be addressed as part of this fall protection plan. This uncovering is to be done at the erection foreman's direction and will only occur immediately prior to feeding the column through the opening. Once the end of the column is through the slab opening, there will no longer exist a fall hazard at this location. 3. Implementation of fall protection plan. The structure being erected is a multi-story total precast concrete building consisting of columns, beams, wall panels and hollow core slabs in double T-floor and roof members. The following is a list of the products and erection situations on this job. Columns. For columns 10 feet to 36 feet long, employees disconnecting crane hooks from columns will work from a ladder and wear a body belt/harness with lanyard and be tied off when both hands are needed to disconnect. For tying off, a vertical lifeline will be connected to the lifting eye at the top of the column, prior to lifting, to be used with a manually operated or mobile rope grab. For columns too high for the use of a ladder, 36 feet and higher, an added cable will be used to reduce the height of the disconnecting point so that a ladder can be used. This cable will be left in place until a point in erection that it can be removed safely. In some cases, columns will be unhooked from the crane by using an erection tube or shackle with a pull pin which is released from the ground after the column is stabilized. The column will be adequately connected and/or braced to safely support the weight of a ladder with an employee on it. Inverted T-beams. Employees erecting inverted T-beams at a height of 6 to 40 feet will erect the beam, make initial connections, and final alignment from a ladder. If the employee needs to reach over the side of the beam to bar or make an adjustment to the alignment of the beam, they will mount the beam and be tied off to the lifting device in the beam after ensuring the load has been stabilized on its bearing. To disconnect the crane from the beam, an employee will stand a ladder against the beam. Because the use of ladders is not practical at heights above 40 feet, beams will be initially placed with the use of taglines and their final alignment made by a person on a man lift or similar employee positioning systems. Spandrel beams at the exterior of the building will be aligned as closely as possible with the use of taglines, with the final placement of the spandrel beam made from a ladder at the open end of the structure. A ladder will be used to make the initial connections and a ladder will be used to disconnect the crane. The other end of the beam will be placed by the designated erector from the double T deck under the observation of the safety monitor. The beams will be adequately connected and/or braced to safely support the weight of a ladder with an employee on it. Floor and roof members. During installation of the precast concrete floor and/or roof members, the work deck continuously increases in area as more and more units are being erected and positioned. Thus, the unprotected floor/roof perimeter is constantly modified with the leading edge changing location as each member is installed. The fall protection for workers at the leading edge shall be assured by properly constructed and maintained control zone lines not more than 60 feet away from the leading edge, supplemented by a safety monitoring system to ensure the safety of all designated erectors working within the area defined by the control zone lines. The hollow core slabs erected on the masonry portion of the building will be erected and grouted using the safety monitoring system. Grout will be placed in the space between the end of the slab and face shell of the concrete masonry by dumping from a wheelbarrow. The grout in the keyways between the slabs will be dumped from a wheelbarrow and then spread with long-handled tools, allowing the worker to stand erect facing toward the unprotected edge and back from any workdeck edge. Whenever possible, the designated erectors will approach the incoming member at the leading edge only after it is below waist height so that the member itself provides protection against falls. Except for the situations described below, when the arriving floor or roof member is within 2 to 3 inches of its final position, the designated erectors can then proceed to their position of erection at each end of the member under the control of the safety monitor. Crane hooks will be unhooked from double T members by designated erectors under the direction and supervision of the safety monitor. Designated erectors, while waiting for the next floor or roof member, will be constantly under the control of the safety monitor for fall protection and are directed to stay a minimum of 6 ft from the edge. In the event a designated erector must move from one end of a member, which has just been placed at the leading edge, they must first move away from the leading edge a minimum of 6 feet and then progress to the other end while maintaining the minimum distance of 6 feet at all times. Erection of double Ts, where conditions require bearing of one end into a closed pocket and the other end on a beam ledge, restricting the T-legs from going directly into the pockets, require special considerations. The T-legs that are to bear in the closed pocket must hang lower than those at the beam bearing. The double T will be two-lined in order to elevate one end higher than the other to allow for the low end to be ducked into the closed pocket using the following procedure. The double T will be rigged with a standard 4-way spreader off of the main load line. An additional choker will be attached to the married point of the two-legged spreader at the end of the T that is to be elevated. The double T will be hoisted with the main load line and swung into a position as close as possible to the T's final bearing elevation. When the T is in this position and stabilized, the whip line load block will be lowered to just above the T deck. At this time, two erectors will walk out on the suspended T deck at mid-span of the T member and pull the load block to the end of the T to be elevated and attach the additional choker to the load block. The possibility of entanglement with the crane lines and other obstacles during this two-lining process while raising and lowering the crane block on that second line could be hazardous to an encumbered employee. Therefore, the designated erectors will not tie off during any part of this process. While the designated erectors are on the double T, the safety monitoring system will be used. After attaching the choker, the two erectors then step back on the previously erected T deck and signal the crane operator to hoist the load with the whip line to the elevation that will allow for enough clearance to let the low-end T-legs slide into the pockets when the main load line is lowered. The erector, who is handling the lowered end of the T at the closed pocket bearing, will step out on the suspended T. An erection bar will then be placed between the end of the T-leg and the inside face of the pocketed spandrel member. The T is barred away from the pocketed member to reduce the friction and lateral force against the pocketed member. As the T is being lowered, the other erector remains on the T, which was previously erected to handle the other end. At this point, the T is slowly lowered by the crane to a point where the T-legs can freely slide into the pockets. The erector working the lowered end of the T must keep pressure on the bar between the T and the face of the pocketed spandrel member to very gradually let the T-leg slide into the pocket to its proper bearing dimension. The T is then slowly lowered into its final erected position. The designated erector should be allowed onto the suspended double T, otherwise there is no control over the horizontal movement of the double T, and this movement could knock the spandrel off of its bearing or the column out of plumb. The control necessary to prevent hitting the spandrel can only be done safely from the top of the double T being erected. Load-bearing wall panels. The erection of the load-bearing wall panels on the elevated decks requires the use of a safety monitor and a controlled access zone that is a minimum of 25 feet and a maximum of 1/2 the length of the wall panels away from the unprotected edge, so that designated erectors can move freely and unencumbered when receiving the panels. Bracing, if required for stability, will be installed by ladder. After the braces are secured, the crane will be disconnected from the wall by using a ladder. The wall-to-wall connections will also be performed from a ladder. Non-load-bearing panels, cladding. The locating of survey lines, panel layout, and other installation prerequisites, pre-welding, etc., for non-load-bearing panels, cladding, will not commence until floor perimeter and floor openings have been protected. In some areas, it is necessary because of panel configuration to remove the perimeter protection as the cladding is being installed. Removal of perimeter protection will be performed on a bay-to-bay basis, just ahead of cladding erection to minimize temporarily unprotected floor edges. Those workers within 6 feet of the edge, receiving and positioning the cladding when the perimeter protection is removed shall be tied off. Detailing. Employees exposed to falls of 6 feet or more to lower levels, who are not actively engaged in leading edge work or connecting activity, such as welding, bolting, cutting, bracing, guying, patching, painting or other operations, and who are working less than 6 feet from an unprotected edge will be tied off at all times or guardrails will be installed. Employees engaged in these activities but who are more than 6 feet from an unprotected edge as defined by the control zone lines do not require fall protection, but a warning line or control lines must be erected to remind employees they are approaching an area where fall protection is required. 4. Conventional fall protection considered for the point of erection or leading edge erection operations. Personal fall arrest systems. In this particular erection sequence and procedure, personal fall arrest systems requiring body belt/harness systems, lifelines and lanyards will not reduce possible hazards to workers and will create offsetting hazards during their usage at the leading edge of precast/pre-stressed concrete construction. Leading edge erection and initial connections are conducted by employees who are specifically trained to do this type of work and are trained to recognize the fall hazards. The nature of such work normally exposes the employee to the fall hazard for a short period of time, and installation of fall protection systems for a short duration is not feasible because it exposes the installers of the system to the same fall hazard, but for a longer period of time. 1. It is necessary that the employee be able to move freely without encumbrance in order to guide the sections of precast concrete into their final position without having lifelines attached, which will restrict the employee's ability to move about at the point of erection. 2. A typical procedure requires 2 or more workers to maneuver around each other as a concrete member is positioned to fit into the structure. If they are each attached to a lifeline, part of their attention must be diverted from their main task of positioning a member weighing several tons to the task of avoiding entanglements of their lifelines or avoiding tripping over lanyards. Therefore, if these workers are attached to lanyards, more fall potential would result than from not using such a device. In this specific erection sequence and procedure, retractable lifelines do not solve the problem of 2 workers becoming tangled. In fact, such a tangle could prevent the lifeline from retracting as the worker moved, thus potentially exposing the worker to a fall greater than 6 feet. Also, a worker crossing over the lifeline of another worker can create a hazard because the movement of one person can unbalance the other. In the event of a fall by one person, there is a likelihood that the other person will be caused to fall as well. In addition, if contamination such as grout, during hollow core grouting, enters the retractable housing, it can cause excessive wear and damage to the device and could clog the retracting mechanism as the lanyard is dragged across the deck. Obstructing the cable orifice can defeat the device's shock-absorbing function, produce cable slack and damage, and adversely affect cable extraction and retraction. 3. Employees tied to a lifeline can be trapped and crushed by moving structural members if the employee becomes restrained by the lanyard or retractable lifeline and cannot get out of the path of the moving load. The sudden movement of a precast concrete member being raised by a crane can be caused by a number of factors. When this happens, a connector may immediately have to move a considerable distance to avoid injury. If a tied-off body belt/harness is being used, the connector could be trapped. Therefore, there is a greater risk of injury if the connector is tied to the structure for this specific erection sequence and procedure. When necessary to move away from a retractable device, the worker cannot move at a rate greater than the device locking speed, typically 3.5 to 4.5 feet per second. When moving toward the device, it is necessary to move at a rate which does not permit cable slack to build up. This slack may cause cable retraction acceleration and cause a worker to lose their balance by applying a higher than normal jerking force on the body when the cable suddenly becomes taut after building up momentum. This slack can also cause damage to the internal spring-loaded drum, uneven coiling of cable on the drum, and possible cable damage. The factors causing sudden movements for this location include: A. Cranes. 1. Operator error. 2. Site conditions, soft or unstable ground. 3. Mechanical failure. 4. Structural failure. 5. Rigging failure. 6. Crane signal/radio communication failure. B. Weather conditions. 1. Wind, strong wind/sudden gusting, particularly a problem with the large surface areas of precast concrete members. 2. Snow/rain, visibility. 3. Fog, visibility. 4. Cold, causing slowed reactions or mechanical problems. C. Structure/product conditions. 1. Lifting eye failure. 2. Bearing failure or slippage. 3. Structure shifting. 4. Bracing failure. 5. Product failure. D. Human error. 1. Incorrect tagline procedure. 2. Tagline hang-up. 3. Incorrect or misunderstood crane signals. 4. Misjudged elevation of member. 5. Misjudged speed of member. 6. Misjudged angle of member. 4. Anchorages or special attachment points could be cast into the precast concrete members if sufficient pre-planning and consideration of erector's position is done before the members are cast. Any hole or other attachment must be approved by the engineer who designed the member. It is possible that some design restrictions will not allow a member to be weakened by an additional hole. However, it is anticipated that such situations would be the exception, not the rule. Attachment points, other than on the deck surface, will require removal and/or patching. In order to remove and/or patch these points, requires the employee to be exposed to an additional fall hazard at an unprotected perimeter. The fact that attachment points could be available anywhere on the structure does not eliminate the hazards of using these points for tying off as discussed above. A logical point for tying off on double T's would be using the lifting loops, except that they must be cut off to eliminate a tripping hazard at an appropriate time. 5. Providing attachment at a point above the walking/working surface would also create fall exposures for employees installing their devices. Final positioning of a precast concrete member requires it to be moved in such a way that it must pass through the area that would be occupied by the lifeline and the lanyards attached to the point above. Resulting entanglements of lifelines and lanyards on a moving member could pull employees from the work surface. Also, the structure is being created and, in most cases, there is no structure above the members being placed. A. Temporary structural supports, installed to provide attaching points for lifelines, limit the space which is essential for orderly positioning, alignment and placement of the precast concrete members. To keep the lanyards a reasonable and manageable length, lifeline supports would necessarily need to be in proximity to the positioning process. A sudden shift of the precast concrete member being positioned because of wind pressure or crane movement could make it strike the temporary supporting structure, moving it suddenly and causing tied-off employees to fall. B. The time and man-hours which would be expended in placing and maintaining temporary structural supports for lifeline attaching points could exceed the expended man-hours involved in placing the precast concrete members. No protection could be provided for the employees erecting the temporary structural supports, and these supports would have to be moved for each successive step in the construction process, thus greatly increasing the employee's exposure to the fall hazard. C. The use of a cable strung horizontally between two columns to provide tie-off lines for erecting or walking a beam for connecting work is not feasible and creates a greater hazard on this multi-story building for the following reasons. 1. If a connector is to use such a line, it must be installed between the two columns. To perform this installation requires an erector to have more fall exposure time attaching the cable to the columns than would be spent to make the beam-to-column connection itself. 2. If such a line is to be installed so that an erector can walk along a beam, it must be overhead or below him. For example, if a connector must walk along a 24 inches wide beam, the presence of a line next to the connector at waist level, attached directly to the columns, would prevent the connector from centering their weight over the beam and balancing themselves. Installing the line above the connector might be possible on the first level of a two-story column. However, the column may extend only a few feet above the floor level at the second level or be flush with the floor level. Attaching the line to the side of the beam could be a solution, however, it would require the connector to attach the lanyard below foot level, which would most likely extend a fall farther than 6 feet. 3. When lines are strung over every beam, it becomes more and more difficult for the crane operator to lower a precast concrete member into position without the member becoming fouled. Should the member become entangled, it could easily dislodge the line from a column. If a worker is tied to it at the time, a fall could be caused. 6. The ANSI A10.14-1991 American National Standard for Construction and Demolition Operations requirements for safety belts, harnesses, lanyards and lifelines for construction and demolition use states that the anchor point of a lanyard or deceleration device should, if possible, be located above the wearer's belt or harness attachment. ANSI A10.14 also states that a suitable anchorage point is one which is located as high as possible to prevent contact with an obstruction below should the worker fall. Most manufacturers also warn in the user's handbook that the safety block/retractable lifeline must be positioned above the D-ring, above the workspace of the intended user, and OSHA recommends that fall arrest and restraint equipment be used in accordance with the manufacturer's instructions. Attachment of a retractable device to a horizontal cable near floor level or using the inserts in the floor or roof members may result in increased free fall due to the dorsal D-ring of the full-body harness riding higher than the attachment point of the snap hook to the cable or insert, e.g., 6-foot-tall worker with a dorsal D-ring at 5 feet above the floor or surface, reduces the working length to only 1 foot by placing the anchorage 5 feet away from the fall hazard. In addition, impact loads may exceed maximum fall arrest forces, MAF, because the fall arrest D-ring would be 4 to 5 feet higher than the safety block/retractable lifeline anchored to the walking working surface, and the potential for swing hazards is increased. Manufacturers also require that workers not work at a level where the point of snap hook attachment to the body harness is above the device because this will increase the free fall distance and the deceleration distance and will cause higher forces on the body in the event of an accidental fall. Manufacturers recommend an anchorage for the retractable lifeline which is immovably fixed in space and is independent of the user's support systems. A movable anchorage is one which can be moved around, such as equipment or wheeled vehicles, or which can deflect substantially under shock loading, such as a horizontal cable or very flexible beam. In the case of a very flexible anchorage, a shock load applied to the anchorage during fall arrest can cause oscillation of the flexible anchorage such that the retractable brake mechanism may undergo one or more cycles of locking/unlocking/locking, ratchet effect, until the anchorage deflection is dampened. Therefore, use of a movable anchorage involves critical engineering and safety factors and should only be considered after fixed anchorage has been determined to be not feasible. Horizontal cables used as an anchorage present an additional hazard due to amplification of the horizontal component of maximum arrest force of a fall, transmitted to the points where the horizontal cable is attached to the structure. This amplification is due to the angle of sag of a horizontal cable and is most severe for small angles of sag. For a cable sag angle of 2 degrees, the horizontal force on the points of cable attachment can be amplified by a factor of 15. It is also necessary to install the retractable device vertically overhead to minimize swing falls. If an object is in the worker's swing path, or that of the cable, hazardous situations exist. 1. Due to the swing, horizontal speed of the user may be high enough to cause injury when an obstacle in the swing fall path is struck by either the user or the cable. 2. The total vertical fall distance of the user may be much greater than if the user had fallen only vertically without a swing fall path. With retractable lines, overconfidence may cause the worker to engage in inappropriate behavior, such as approaching the perimeter of a floor or roof at a distance appreciably greater than the shortest distance between the anchorage point and the leading edge. Though the retractable lifeline may arrest a worker's fall before he or she has fallen a few feet, the lifeline may drag along the edge of the floor or beam and swing the worker like a pendulum until the line has moved to a position where the distance between the anchorage point and floor edge is the shortest distance between those 2 points. Accompanying this pendulum swing is a lowering of the worker, with the attendant danger that he or she may violently impact the floor or some obstruction below. The risk of a cable breaking is increased if a lifeline is dragged sideways across the rough surface or edge of a concrete member at the same moment that the lifeline is being subjected to a maximum impact loading during a fall. The typical 3/16 inch cable in a retractable lifeline has a breaking strength of from 3,000 to 3,700 pounds. 7. The competent person, who can take into account the specialized operations being performed on this project, should determine when and where a designated erector cannot use a personal fall arrest system. B. Safety net systems. The nature of this particular precast concrete erection worksite precludes the safe use of safety nets where point of erection or leading edge work must take place. To install safety nets in the interior high bay of the single-story portion of the building poses rigging attachment problems. Structural members do not exist to which supporting devices for nets can be attached in the area where protection is required. As the erection operation advances, the location of point of erection or leading edge work changes constantly as each member is attached to the structure. Due to this constant change, it is not feasible to set net sections and build separate structures to support the nets. 2. The nature of the erection process for the precast concrete members is such that an installed net would protect workers as they position and secure only one structural member. After each member is stabilized, the net would have to be moved to a new location. This could mean a move of 8 to 10 feet or the possibility of a move to a different level or area of the structure to protect workers placing the next piece in the construction sequence. The result would be the installation and dismantling of safety nets repeatedly throughout the normal workday. As the time necessary to install a net, test, and remove it is significantly greater than the time necessary to position and secure a precast concrete member, the exposure time for the worker installing the safety net would be far longer than for the workers whom the net is intended to protect. The time exposure repeats itself each time the nets and supporting hardware must be moved laterally or upward to provide protection at the point of erection or leading edge. 3. Strict interpretation of 1926.502(c) requires that operation shall not be undertaken until the net is in place and has been tested. With the point of erection constantly changing, the time necessary to install and test a safety net significantly exceeds the time necessary to position and secure the concrete member. 4. Use of safety nets on exposed perimeter wall openings and open-sided floors causes attachment points to be left in architectural concrete, which must be patched and filled with matching material after the net supporting hardware is removed. In order to patch these openings, additional numbers of employees must be suspended by swing stages, bosun chairs, or other devices, thereby increasing the amount of fall exposure time to employees. 5. Installed safety nets pose an additional hazard at the perimeter of the erected structure where limited space is available in which members can be turned after being lifted from the ground by the crane. There would be a high probability that the member being lifted could become entangled in net hardware, cables, etc. 6. The use of safety nets where structural wall panels are being erected would prevent movement of panels to point of installation. To be effective, nets would necessarily have to provide protection across the area where structural supporting wall panels would be set and plumbed before roof units could be placed. 7. Use of a tower crane for the erection of the high-rise portion of the structure poses a particular hazard in that the crane operator cannot see or judge the proximity of the load in relation to the structure or nets. If the signaler is looking through nets and supporting structural devices while giving instructions to the crane operator, it is not possible to judge precise relationships between the load and the structure itself or to nets and supporting structural devices. This could cause the load to become entangled in the net or hit the structure, causing potential damage. C. Guardrail systems. On this particular worksite, guardrails, barricades, ropes, cables, or other perimeter guarding devices or methods on the erection floor will pose problems to safe erection procedures. Typically, a floor or roof is erected by placing 4 to 10 feet wide structural members next to one another and welding or grouting them together. The perimeter of a floor and roof changes each time a new member is placed into position. It is unreasonable and virtually impossible to erect guardrails and toe boards at the ever-changing leading edge of a floor or roof. 1. To position a member safely, it is necessary to remove all obstructions extending above the floor level near the point of erection. Such a procedure allows workers to swing a new member across the erected surface as necessary to position it properly without worrying about knocking material off of this surface. Hollow core slab erection on the masonry wall requires installation of the perimeter protection where the masonry wall has to be constructed. This means the guardrail is installed then subsequently removed to continue the masonry construction. The erector will be exposed to a fall hazard for a longer period of time while installing and removing perimeter protection than while erecting the slabs. In hollow core work, as in other precast concrete erection, others are not typically on the work deck until the precast concrete erection is complete. The deck is not complete until the leveling, aligning, and grouting of the joints is done. It is normal practice to keep others off the deck until at least the next day after the installation is complete to allow the grout to harden. 2. There is no permanent boundary until all structural members have been placed in the floor or roof. At the leading edge, workers are operating at the temporary edge of the structure as they work to position the next member in the sequence. Compliance with the standard would require a guardrail and toe board be installed along this edge. However, the presence of such a device would prevent a new member from being swung over the erected surface low enough to allow workers to control it safely during the positioning process. Further, these employees would have to work through the guardrail to align the new member and connect it to the structure. The guardrail would not protect an employee who must lean through it to do the necessary work, rather it would hinder the employee to such a degree that a greater hazard is created than if the guardrail were absent. 3. Guardrail requirements pose a hazard at the leading edge of installed floor or roof sections by creating the possibility of employees being caught between guardrails and suspended loads. The lack of a clear work area in which to guide the suspended load into position for placement and welding of members into the existing structure creates still further hazards. For where erection processes require precast concrete stairways or openings to be installed as an integral part of the overall erection process, it must also be recognized that guardrails or handrails must not project above the surface of the erection floor. Such guardrails should be terminated at the level of the erection floor to avoid placing hazardous obstacles in the path of a member being positioned. Other fall protection measures considered for this job. The following is a list and explanation of other fall protection measures available and an explanation of limitations for use on this particular job site. If during the course of erecting the building the employee sees an area that could be erected more safely by the use of these fall protection measures, the foreman should be notified. A. Scaffolds are not used because 1. The leading edge of the building is constantly changing and the scaffolding would have to be moved at very frequent intervals. Employees erecting and dismantling the scaffolding would be exposed to fall hazards for a greater length of time than they would by merely erecting the precast concrete member. 2. A scaffold tower could interfere with the safe swinging of a load by the crane. 3. Power lines, terrain and site do not allow for the safe use of scaffolding. B. Vehicle-mounted platforms are not used because 1. A vehicle-mounted platform will not reach areas on the deck that are erected over other levels. 2. The leading edge of the building is usually over a lower level of the building and this lower level will not support the weight of a vehicle-mounted platform. 3. A vehicle-mounted platform could interfere with the safe swinging of a load by the crane, either by the crane swinging the load over or into the equipment. 4. Power lines and surrounding site work do not allow for the safe use of a vehicle-mounted platform. C. Crane suspended personnel platforms are not used because 1. A second crane close enough to suspend any employee in the working and erecting area could interfere with the safe swinging of a load by the crane hoisting the product to be erected. 2. Power lines and surrounding site work do not allow for the safe use of a second crane on the job. 6. Enforcement. Constant awareness of and respect for fall hazards, and compliance with all safety rules are considered conditions of employment. The job site superintendent, as well as individuals in the Safety and Personnel Department, reserve the right to issue disciplinary warnings to employees, up to and including termination, for failure to follow the guidelines of this program. 7. Accident investigations. All accidents that result in injury to workers, regardless of their nature, shall be investigated and reported. It is an integral part of any safety program that documentation take place as soon as possible so that the cause and means of prevention can be identified to prevent a reoccurrence. In the event that an employee falls or there is some other related, serious incident occurring, this plan shall be reviewed to determine if additional practices, procedures, or training need to be implemented to prevent similar types of falls or incidents from occurring. 8. Changes to plan. Any changes to the plan will be approved by name of the qualified person. This plan shall be reviewed by a qualified person as the job progresses to determine if additional practices, procedures, or training needs to be implemented by the competent person to improve or provide additional fall protection. Workers shall be notified and trained, if necessary, in the new procedures. A copy of this plan and all approved changes shall be maintained at the job site. Sample Fall Protection Plan for Residential Construction, insert company name. This fall protection plan is specific for the following project. Location of job. Date plan prepared or modified. Plan prepared by. Plan approved by. Plan supervised by. The following fall protection plan is a sample program prepared for the prevention of injuries associated with falls. A fall protection plan must be developed and evaluated on a site-by-site basis. It is recommended that builders discuss the written fall protection plan with their OSHA area office prior to going on a job site. Statement of company policy. Your company name here is dedicated to the protection of its employees from on-the-job injuries. All employees of your company name here have the responsibility to work safely on the job. The purpose of the plan is to supplement our existing safety and health program and to ensure that every employee who works for your company name here recognizes workplace fall hazards and takes the appropriate measures to address those hazards. This fall protection plan addresses the use of conventional fall protection at a number of areas on the project, as well as identifies specific activities that require non-conventional means of fall protection. During the construction of residential buildings under 48 feet in height, it is sometimes infeasible or it creates a greater hazard to use conventional fall protection systems at specific areas or for specific tasks. The areas or tasks may include, but are not limited to, setting and bracing of roof trusses and rafters, the installation of floor sheathing and joists, C. Roof sheathing operations, and D. Erecting exterior walls. In these cases, conventional fall protection systems may not be the safest choice for builders. This plan is designed to enable employers and employees to recognize the fall hazards associated with this job and to establish the safest procedures that are to be followed in order to prevent falls to lower levels or through holes and openings in walking/working surfaces. Each employee will be trained in these procedures and will strictly adhere to them except when doing so would expose the employee to a greater hazard. If, in the employee's opinion, this is the case, the employee is to notify the competent person of their concern and have the concern addressed before proceeding. It is the responsibility of, name of competent person, to implement this fall protection plan. Continual observational safety checks of work operations and the enforcement of the safety policy and procedures shall be regularly enforced. The crew supervisor or foreman, insert name, is responsible for correcting any unsafe practices or conditions immediately. It is the responsibility of the employer to ensure that all employees understand and adhere to the procedures of this plan and to follow the instructions of the crew supervisor. It is also the responsibility of the employee to bring to management's attention any unsafe or hazardous conditions or practices that may cause injury to either themselves or any other employees. Any changes to the fall protection plan must be approved by name of qualified person. 2. Fall protection systems to be used on this job. Installation of roof trusses/rafters, exterior wall erection, roof sheathing, floor sheathing and joist/truss activities will be conducted by employees who are specifically trained to do this type of work and are trained to recognize the fall hazards. The nature of such work normally exposes the employee to the fall hazard for a short period of time. This plan details how your company name here will minimize these hazards. Controlled access zones. When using the plan to implement the fall protection options available, workers must be protected through limited access to high hazard locations. Before any non-conventional fall protection systems are used as part of the work plan, a controlled access zone (CAZ) shall be clearly defined by the competent person as an area where a recognized hazard exists. The demarcation of the CAZ shall be communicated by the competent person in a recognized manner, either through signs, wires, tapes, ropes or chains. Your company name here shall take the following steps to ensure that the CAZ is clearly marked or controlled by the competent person. All access to the CAZ must be restricted to authorized entrance. All workers who are permitted in the CAZ shall be listed in the appropriate sections of the plan, or be visibly identifiable by the competent person, prior to implementation. The competent person shall ensure that all protective elements of the CAZ be implemented prior to the beginning of work. Installation procedures for roof truss and rafter erection. During the erection and bracing of roof trusses/rafters, conventional fall protection may present a greater hazard to workers. On this job, safety nets, guardrails and personal fall arrest systems will not provide adequate fall protection because the nets will cause the walls to collapse, while there are no suitable attachment or anchorage points for guardrails or personal fall arrest systems. On this job, requiring workers to use a ladder for the entire installation process will cause a greater hazard because the worker must stand on the ladder with his back or side to the front of the ladder. While erecting the truss or rafter, the worker will need both hands to maneuver the truss and therefore cannot hold onto the ladder. In addition, ladders cannot be adequately protected from movement while trusses are being maneuvered into place. Many workers may experience additional fatigue because of the increase in overhead work with heavy materials, which can also lead to a greater hazard. Exterior scaffolds cannot be utilized on this job because the ground, after recent backfilling, cannot support the scaffolding. In most cases, the erection and dismantling of the scaffold would expose workers to a greater fall hazard than erection of the trusses/rafters. On all walls 8 feet or less, workers will install interior scaffolds along the interior wall below the location where the trusses/rafters will be erected. Sawhorse scaffolds constructed of 46-inch sawhorses and 2x10 planks will often allow workers to be elevated high enough to allow for the erection of trusses and rafters without working on the top plate of the wall. In structures that have walls higher than 8 feet and where the use of scaffolds and ladders would create a greater hazard, safe working procedures will be utilized when working on the top plate and will be monitored by the crew supervisor. During all stages of truss/rafter erection, the stability of the trusses/rafters will be ensured at all times. Your company name here shall take the following steps to protect workers who are exposed to fall hazards while working from the top plate installing trusses/rafters. Only the following trained workers will be allowed to work on the top plate during roof truss or rafter installation. Workers shall have no other duties to perform during truss/rafter erection procedures. All trusses/rafters will be adequately braced before any worker can use the truss/rafter as a support. Workers will remain on the top plate using the previously stabilized truss/rafter as a support while other trusses/rafters are being erected. Workers will leave the area of the secured trusses only when it is necessary to secure another truss/rafter. The first 2 trusses/rafters will be set from ladders leaning on side walls at points where the walls can support the weight of the ladder, and a worker will climb onto the interior top plate via a ladder to secure the peaks of the first 2 trusses/rafters being set. The workers responsible for detaching trusses from cranes and or securing trusses at the peaks traditionally are positioned at the peak of the trusses/rafters. There are also situations where workers securing rafters to ridge beams will be positioned on top of the ridge beam. Your company name here shall take the following steps to protect workers who are exposed to fall hazards while securing trusses/rafters at the peak of the trusses/ridge beam. Only the following trained workers will be allowed to work at the peak during roof truss or rafter installation. Once truss or rafter installation begins, workers not involved in that activity shall not stand or walk below or adjacent to the roof opening or exterior walls in any area where they could be struck by falling objects. Workers shall have no other duties than securing/bracing the trusses/ridge beam. Workers positioned at the peaks or in the webs of trusses or on top of the ridge beam shall work from a stable position, either by sitting on a ridge seat or other equivalent surface that provides additional stability, or by positioning themselves in previously stabilized trusses/rafters and leaning into and reaching through the trusses/rafters. Workers shall not remain on or in the peak/ridge any longer than necessary to safely complete the task. Roof sheathing operations. Workers typically install roof sheathing after all trusses/rafters and any permanent truss bracing is in place. Roof structures are unstable until some sheathing is installed, so workers installing roof sheathing cannot be protected from fall hazards by conventional fall protection systems until it is determined that the roofing system can be used as an anchorage point. At that point, employees shall be protected by a personal fall arrest system. Trusses/rafters are subject to collapse if a worker falls while attached to a single truss with a belt/harness. Nets could also cause collapse, and there is no place to attach guardrails. All workers will ensure that they have secure footing before they attempt to walk on the sheathing, including cleaning shoes/boots of mud or other slip hazards. To minimize the time workers must be exposed to a fall hazard, materials will be staged to allow for the quickest installation of sheathing. Your company name here shall take the following steps to protect workers who are exposed to fall hazards while installing roof sheathing. Once roof sheathing installation begins, workers not involved in that activity shall not stand or walk below or adjacent to the roof opening or exterior walls in any area where they could be struck by falling objects. The competent person shall determine the limits of this area, which shall be clearly communicated to workers prior to placement of the first piece of roof sheathing. The competent person may order work on the roof to be suspended for brief periods as necessary to allow other workers to pass through such areas when this would not create a greater hazard. Only qualified workers shall install roof sheathing. The bottom row of roof sheathing may be installed by workers standing in truss webs. After the bottom row of roof sheathing is installed, a slide guard extending the width of the roof shall be securely attached to the roof. Slide guards are to be constructed of no less than nominal 4-inch height, capable of limiting the uncontrolled slide of workers. Workers should install the slide guard while standing in truss webs and leaning over the sheathing. Additional rows of roof sheathing may be installed by workers positioned on previously installed rows of sheathing. A slide guard can be used to assist workers in retaining their footing during successive sheathing operations, and additional slide guards shall be securely attached to the roof at intervals not to exceed 13 feet as successive rows of sheathing are installed. For roofs with pitches in excess of 9 and 12, slide guards will be installed at 4-foot intervals. When wet weather, rain, snow, or sleet are present, roof sheathing operations shall be suspended unless safe footing can be assured for those workers installing sheathing. When strong winds, above 40 miles per hour, are present, roof sheathing operations are to be suspended unless windbreakers are erected. Installation of floor joists and sheathing. During the installation of floor sheathing/joists, leading edge construction, the following steps shall be taken to protect workers. Only the following trained workers will be allowed to install floor joists or sheathing. Materials for the operation shall be conveniently staged to allow for easy access to workers. The first floor joists or trusses will be rolled into position and secured either from the ground, ladders, or sawhorse scaffolds. Each successive floor joist or truss will be rolled into place and secured from a platform created from a sheet of plywood laid over the previously secured floor joists or trusses. Except for the first row of sheathing, which will be installed from ladders or the ground, workers shall work from the established deck, and any workers not assisting in the leading edge construction while leading edges still exist, e.g. cutting the decking for the installers, shall not be permitted within 6 feet of the leading edge under construction. Erection of exterior walls. During the construction and erection of exterior walls, employers shall take the following steps to protect workers. Only the following trained workers will be allowed to erect exterior walls. A painted line 6 feet from the perimeter will be clearly marked prior to any wall erection activities to warn of the approaching unprotected edge. Materials for operations shall be conveniently staged to minimize fall hazards, and workers constructing exterior walls shall complete as much cutting of materials and other preparation as possible away from the edge of the deck. 3. Enforcement. Constant awareness of and respect for fall hazards, and compliance with all safety rules are considered conditions of employment. The crew supervisor or foreman, as well as individuals in the Safety and Personnel Department, reserve the right to issue disciplinary warnings to employees, up to and including termination, for failure to follow the guidelines of this program. 4. Accident investigations. All accidents that result in injury to workers, regardless of their nature, shall be investigated and reported. It is an integral part of any safety program that documentation take place as soon as possible so that the cause and means of prevention can be identified to prevent a reoccurrence. In the event that an employee falls or there is some other related, serious incident occurring, this plan shall be reviewed to determine if additional practices, procedures, or training need to be implemented to prevent similar types of falls or incidents from occurring. Via changes to plan. Any changes to the plan will be approved by name of the qualified person. This plan shall be reviewed by a qualified person as the job progresses to determine if additional practices, procedures, or training needs to be implemented by the competent person to improve or provide additional fall protection. Workers shall be notified and trained, if necessary, in the new procedures. A copy of this plan and all approved changes shall be maintained at the job site.